Hello, myself Dr. Vijaya Chandra Jadala welcomes you to today's session on Introduction to Cloud Computing. I, Dr. Vijaya Chandra Jadala, Associate Professor, Department of Computer Science and Artificial Intelligence, School of Computer Science and Artificial Intelligence, SR University, Warangal. The session today I am going to discuss is Introduction to Cloud Computing, which is the first session related to the cloud computing series. In this particular session I am going to discuss related to the role of cloud computing, characteristics of cloud computing, evaluation as well as the challenges of the cloud computing, whereas I am going to compare the AWS architecture with traditional IT, then comes to the global infrastructure. So all these different topics are going to be discussed related to the cloud computing. Let us start with the first step, that is cloud computing definition, whereas it's part of an introductory to the cloud computing. Cloud computing is an ambiguous, convenient, on-demand network access to a shared pool of configurable computing resources. Example: networks, servers, storage applications and services that can be rapidly provisioned and released with minimal management effort and service provider interaction. This cloud model is composed of 5 essential characters, 3 service models and 4 deployment models. So here the cloud model is an on-demand network access model where it can share the different servers, storages and applications to the consumer or customer. Then comes to the different models essential characteristics. The essential characteristics are on-demand, self-service, broad network access, then comes to the resource pooling, then rapid elasticity and measured services. So these are the different 5 services which comes under the essential models. Then comes to the service models. The service models are software as a service, which is considered as SaaS, then platform as a service, which is considered as PaaS, then comes to the infrastructure as a service, which is considered as IaaS. So these are the different services where it will provide the software, where it will provide the different platforms, where it will provide the infrastructure. These are all considered as the service models. Then comes to the deployment model. So the deployment models are majorly 4. One is the private cloud, public cloud, then comes to the community cloud and hybrid cloud. Hybrid cloud has all the good qualities of private and public as well as community clouds. So here by combination of different clouds is considered as an hybrid cloud. So in deployment model we are having 4 different clouds, that is public cloud, community cloud, private cloud and hybrid cloud. Then comes to the essential characteristics, the different characteristics which we are going to see here is, the first one is on demand self-service. So as per the requirement of your requirement you are going to check the services that consider as the on-demand self-service. So here computing resources will be available and no need for any human interaction, that means any salesperson or to wait for an IT administrator to get the things done. Here everything will be available through your portal or application API provision resources, and you can use them as per your requirement, on demand self-service. So here majorly as I am comparing with the AWS cloud, the AWS launches a virtual server by using EC2, AWS EC2, which is considered as elastic cloud compute. So here the different services which will be provided here is where you can use the virtual servers, or you can use the network, or you can use the storage, and you can use the security group. So different available services you can use as per your requirement, that is considered as a on demand self service. Then comes to the next consideration related to related to our topic, that is broad network access. The broad network access is you can access the network cloud services through the internet connection, and wide variety of devices can be connected through this particular network. So here the applications can be accessed through mobile phones, laptops, computers and workstations. And here an example is taken as a Google Drive. If you are having a Google Drive where you can access the things, from any of the devices. The devices may be a laptop, device may be a desktop, device may be a mobile phone, or device may be a iPad. So here any device, it can be connected and through the network, that is considered as an internet. So here next comes to the resource pooling. So till now what we discussed is on demand self service, broad network access, resource pooling. So now the resource pooling is a where you can use the resources such as hardwares, servers, then storage devices, storages, then networks, where these all will be connected to one particular resource pool, and dynamically as per your requirement, as per your need, you can use these particular resources. That's considered as a resource pooling. So multiple virtual machines can be used by this particular resource pooling option or characteristic. Then comes to the rapid elasticity. As per your requirement, you are going to use the services, and you are going to pay the services as per the requirement, and cloud resources can be quickly and automatically expand and shrink as per the demand. Let's take an example. This year you have 100 employees and you have around 10 projects. Then whatever resources you use, you procure them, and next year if you need more resources, then also you can expand, and if you want less resources, then also you can use. Whereas this provision is not available in the not available in the traditional IT sector. Then comes to the measured services. So here you are going to not only think about the rapid elasticity, then comes to the measured services. As per the services which you are going to use, that will be measured and billed for you. That means the cloud usage will track and bill on basis of the consumption, how far you are going to consume. Based on it, it will track and it will bill the concepts, and this provides you the transparency of the users to pay only what they use. So one of the particular characteristic is measured service. That means that pay what you are going to use. So here in this particular concept, in cloud computing, there are 5 essential characteristics: on-demand self-service, broad network access, resource pooling, rapid elasticity, and finally comes to the measured service. Then once again I am going to discuss regarding these particular concepts, that is on-demand self-service, where a customer can unilaterally provision computing capabilities such as server, time and network storage. So server as well as the network storage as needed automatically without any interaction of human interaction for each service provider. So here automatically through the portal he is going to access, the user is going to access the resources such as the server as well as the network storage. Then comes to the rapid elasticity. Capabilities can be elastically provisioned and released, in some cases automatically. So here it is as per the requirement, it will be provisioned and it will be released automatically as per the requirement. The scale rapidly upward as well as downward and commensurate with the demand. As per the requirement, the scale can be up and the scale can be down as per your consumer requirement. So the capabilities available for the provision of are often be the unlimited and can be appropriated by any quantity of any time. So then comes to the next concept, that is related to the broad network access. So the capabilities are available over the network and accessed through the measurement or mechanisms to be provided by the thin or thick layer of the client platforms. These client platforms are mobile phones, tablets, laptops and workstations. Then finally, before the essential measured services, there is another concept which is known as the resource pooling. So here the providers is computing the resources such as service related to the consumer, how far it is used in the multi-tenant model where the different physical and virtual resources are dynamically assigned as well as reassigned to the customer as per its demand. There is a sense of location related to the customer's generality, that is no control or knowledge of the exact location where this particular data resources are used, but they will be provided, and here it will specify the location at higher level of abstraction, that is from which data center it is used and from which location of this particular data center it is using, but they won't get a clear data related where it is stored. Then comes this, the example of resource includes the storage, processing, memory and network bandwidth. These are the four major resources which we are going to see here. Then comes to the measured services. So all the services provided by the cloud are measured as per the requirement of the client. These services will be measured and the bill will be provided to the client. So here cloud system automatically control and optimize the resources used by the leveraging a metering capability at some level of abstraction appropriate to the types of services. The services here provided are storage, processing, bandwidth and active user accounts. The resource usage can be mounted, controlled and reported, providing the transparency for both the provider as well as the consumer of the utilized service. So here this is all about the measured service, and after this particular measured service, once we are going to revise the what are the cloud computing essential characteristics, that is on demand self-service, broad network access, resource pooling, rapid elasticity, and comes under the next is the measured service. Evolution of cloud computing. The cloud computing journey started at 1950s with the distributed computing concept, and in 2007 the cloud computing concept existed at full-fledged. In between there are so many different concepts such as distributed computing, mainframe computing, cluster computing, grid computing, then the concept of virtualization, then web 2.0, service orientation, utility computing and cloud computing. So let's discuss related to the first model of evolution of computing, that is distributed computing. So here the distributed computing, when we are going to discuss let's take an example. Imagine there is a big task and too many persons are required to complete that particular task. So you are going to break it down into small pieces and you are going to give each piece to different persons. So multiple persons are going to work on a single project and everyone should finish it in a given particular time. Once they finish their particular task, you are going to combine their results and accomplish this particular big task. For this particular purpose, for this particular example, what you need is a multi-connected interconnected computers to a particular server, and where they are going to share the resources, and these particular different pieces of work should be combined at the server. So here the concept comes under the distributed computing. So different computers are interconnected together to work for a single particular problem. This is considered as an distributed computing. So in general, the distributed computing is a paradigm where multiple independent computers work together as a single system to achieve a common goal. So here the distributed computing is a paradigm where multiple independent computers work together as a single system to achieve a particular common goal. These computers often geographically dispersed, that means they will not be at a particular one location. Geographically they may be at different places, but they will communicate with each other through the network. The system appears as a single coherent entry to the end users, even though the different components are distributed and they are connected. This concept is considered as an distributed computing, which started its journey at the early stage of 1950s, and it is the basic step for the cloud computing concept. Next, after this, there is another computing concept which is considered as a mainframe computing, which refers to the large, powerful and highly reliable computing designed for a high volume of machine for a critical applications, majorly bank applications, railway applications, and so many different applications are runs on the mainframe computing. And these systems are typically centralized and handled massive amount of data processing and transaction for large organizations. So they are going to work for the large organization, for example railways, banking sectors and others. So here the mainframe computers think of a giant mainframe, that means they are going to work for a bigger task, and they are powerful and centralized computing system, such as similar, not as a supercomputer, it is somewhat related to the supercomputer, and designed to handle multiple massive amount of transactions, data processing events, and from many users, not from a single user, and the applications will work simultaneously. It is like a central brain for a particular organization. So after this particular mainframe computers, then comes to the cluster computing. So cluster computing means division of the groups. So here cluster computing involves computing a group, independent computing, that is nodes, via a high speed network to work together as a single particular system. These nodes are typically heterogeneous. Some hardware or a software are located in proximity. So the goal of this particular is to provide high availability, load balancing and efficient enhanced power consumption, computational power. So here let's discuss related to this particular cluster computing. Cluster computing is where you are going to imagine the several regular computing connected together so that they can act as a powerful supercomputer. They can share the common purpose as located physically which is close to each other, and the problem is if one computer fails, the other often pick up this particular stack. So here the grid is so the clusters, it's divided into the clusters, and to overcome this advantage, if one computer fails, the total cluster is going to be having a problem. So the next step involved is related to the grid computing. So from first step, that is the distributed computing, the mainframe computer evolved. From mainframe computing, cluster computer evolution occurred. Then after the cluster computing, the grid computing. Grid computing is a form of distributing computing that involves harnessing a computing computational power of many geographical dispersed and heterogeneous computers to solve a single massive computational problem. So here geographically they are not at the same location, but they can solve the particular problem, which is a huge computational problem. It even involves sharing the resources dynamically across this particular organization. So this grid computing is working for a particular organization, means the organization people where they are located in geographically, they can use this particular grid computing concept. Then comes to the virtualization. Virtualization means which is not exactly, it is the technology which will give you the virtual version of the resource. So here the virtual version of the resource, such as operating system, server, storage devices or network resources, rather than the physical version. So virtual version is something like a software where you are going to use. Let's take an example of the hard disk. The hard disk which you are going to use is a physical version, and the drive, Google Drive, which you are going to use is the virtual version. So here this virtualization involves a single physical machine to run multiple isolated virtual machines, that is virtual machines, each with its own operating systems and applications. So this is all about the virtualization. Then after this particular virtualization, then comes to the web technologies, where web 2.0 existed, that is the second generation of World Wide Web is existed. So here it characterized by increased the generated content, interactivity, social networking, collaborative tools, or the concepts which increase the World Wide Web. It shifted the web to the static read-only mechanism to the dynamic read-write and participated platform. Here we have to discuss two different concepts in World Wide Web, that is web technology. One is the static web technology and dynamic web technology. Static web pages are the pages where you can write and you can keep it, where you cannot do changes automatically or dynamically, whereas dynamic is you can read as well as you can write on this particular platform, that comes under the dynamic. So here this evaluation occurred where you can write it dynamically and it will be stored in the servers, database servers or web servers. So this is another achievement related to the evaluation of the cloud computing. Then comes to the service oriented. So service oriented architecture exists. It is an architectural style where the applications are built from loosely coupled to reusable and interoperable services. So these services communicate with each other over a network. So this is all about the based on the standardized protocol. So based on the standardized protocol, service orientation is existed. And after this, then final next is the utility computing. Utility computing is just before the cloud computing. Utility computing is a business model where the computing resources like processing power, storage and applications are provided to the consumer on demand, where you are going to use how your utilities such as electricity bill or water bill, in the same way you are going to get this particular services of utilizing the storage as well as the applications, and the user will pay only for the resources which they consume. So the concept of utility computing is pay only for the resources they consume, and typically based on the usage of metrics. That means how far you are going to use, based on that this particular utility computing exists. So next comes to the cloud computing, which is the computing technology which we are seeing right now and we are discussing till now. So here these are the different concepts related to the cloud computing, and these are the different steps involved in evaluation of the cloud computing. Let's discuss the challenges of cloud computing. The major challenges of cloud computing evolves with security and privacy. Security and privacy is the major challenge related to the cloud. Security plays a major role related to the information which we stored. Security and privacy are the major concepts for protecting the data which is stored at a large quantity in servers, online accounts, and there are a big number of chances such the data may be corrupted through hackers, viruses, or unauthorized persons. So security and privacy plays a major role in data protection for safe and preventing the damage or theft. Privacy is controlling to see the personal information, that how it is used, and it creates a right way to decide what to be shared and not to be shared. So security and privacy are the major concepts here in cloud computing. The security concepts are AAA: authentication, authorization, and auditing. Authentication means who is authenticated through the multi-factor authentication process. The data should be secured. That means through password, and one more authentication process through the OTP to the mobile can be used. Using a strong password and two-factor authentication for your data is as part of security, plays as a procedure for the security. Antivirus software protecting your malware is also one of the major steps related to the security. So security plays a major role where authentication as well as blocking unauthorized access, that is the firewalls, plays a major role in blocking unauthorized access to the database. Encryption of your online transaction plays a major role for security. The security plays a major role with authentication, authorization, and accounting. The next is CIA triad for the information security, which means confidentiality, integrity, and availability. So CIA is the concept which is related to the security, where it plays confidentiality, integrity and availability. The next concept in spite of security is the privacy, where sharing the location at social media or sharing the data at websites, sharing the data at cookies and pop-up windows may keep you in trouble. So cloud, not only the challenge for the cloud is, the major challenge for the cloud is security as well as privacy. Then comes to the interoperability. So the challenges, the next challenge in spite of security and privacy is interoperability. Let's take an example. You have a mobile phone, your friend is also having a mobile phone with another brand, but you can use the charger, both can use the charger. That is a simple example for the interoperability. So here when you are using a document in one software, your friend can open it and edit the software with the problems when it is in the cloud environment. This facility is considered, or the challenge is considered as interoperability. That means from different systems or devices this application can be worked. For example, you are using a Microsoft Excel sheet where you can share with your friend, and from different system and different location he can do the modification. This is one of the characteristic which is considered as an interoperability. Then comes to the portability. One of the other challenge is the portability after the interoperability. So here portability is to know about how easily something can be moved from different places. So the data transfer is considered as the portability. So the data portability is an example where you can copy the data in your Google Drive, or you can copy the data in your USB stick or in your laptop, and that you can transfer. So here the Google Drive is the cloud environment where it will provide you the portability, not only from one location, from different locations you can open it. And software portability is where you can use the Java or Windows or Linux environments, where the Java code can be opened in Windows environment or the Linux environment. That considered as a software portability. Then comes to the web portability. So different websites or web apps can be accessed in different locations in different web browsers. That is considered as a web portability. So cloud computing is deploying an application or characteristics of portability, where you can store the data in cloud and you can use from different situations and different locations. Then after the portability, the next is computing performance. So the performance can be calculated as the computing performance. So the simple explanation for this computing performance is how far or how efficiently your computer system or software application can complete the particular tasks which are provided, and getting the work done quickly and smoothly. So here it depends totally on the performance of the computing. So how far your CPU is working. So not only the CPU, you can use the cloud environment based CPUs to run your work, to complete your work very fastly. For the sake of higher performance CPU, the open CPUs are available where they can work quickly and faster. So the RAM and CPU will place a major role in the division of the uh, computing performance. Then comes to the next step, which is known as reliability. Reliability means depend confidently. When you can depend on a particular system confidently is when it works perfectly without any errors, then it considered as the, then only you can reliable on the particular environment or the system. Here the challenges are related to the cloud computing. As cloud works perfectly, you can confidently rely on the cloud. So this is also one of the challenge. So the total challenges are majorly security, interoperability, portability, cloud performance, and reliability. These are the major 5 challenges occurred in cloud environment. Benefits of cloud computing. The benefits of cloud computing, we are going to discuss the first topic, that is elasticity and scalability. Elasticity and scalability, where the, let's take an example to explain this particular elasticity and scalability. This elasticity and scalability, the scalability, when we discuss related to the scalability, let's take an example that you are running a particular shop. More customers are coming to your shop, so you have to handle them, you have to purchase more shelves, more staff should be hired, and more groceries should be brought from the market. So here you are going to handle the situation. To handle the situation, you are going to increase the scale of purchasing and hiring, as well as for the sake of the groceries which from the market. Whereas let's discuss related to the scalability. After scalability, but when we discuss related to the AWS or any cloud environment, the scale can be as per your requirement. But elasticity, let's take that the shop is running on Saturdays and Sundays more, and you can hire separately for the employees for the Saturdays and Sundays. That means based on the situation, you are going to use the elasticity on current demand, paying only for what you use. So this elasticity and scalability are the advantages of cloud computing, where these help us in identifying the requirements and use the cloud resources and pay how far we used. Elasticity is used to just to meet the sudden growth or down of the workload of a particular period of time. So here elasticity, if it is down or up, it can be scaled at a particular period of time in cloud computing, whereas scalability is used to meet the static increase in the workload, whereas elasticity can be used for the dynamic changes that occurs in the workload to procure the resources and to utilize the resources only for pay what they used. Scalability is always used to address the user requirement related to the workload of an organization. Then after this elasticity and scalability, then comes to the fault tolerance. Fault tolerance is the ability of the workload that remains operational with the zero downtime to data loss and even of a distribution. So here fault tolerance, even though we get the problems occur, it will be solved within the microseconds. Then this facility is there in the cloud computing, so that no need to worry related to the problems occur. Let's take an example. You working on a one particular project, and due to some occurrences, the data may be corrupted, but it can be retrieved as the data is not stored in one particular place. It will be stored in different situations, different data centers all over the world. The copies of the data will be there in the hard disk as mirrors. So these mirrors will be used to retrieve the data from the for the sake of the data retrieval, for the data security. This is one of the ability of the cloud computing, that is the one of the benefit of the cloud computing, which is considered as the fault tolerance. Next comes to the high availability and operational performance. AWS is designed to get the high availability as well as operational performance to its core by enabling the business to build resilient and performant of applications. So here the high availability refers to the ability of the system to remain the operational accessible, which depends upon the futures of disruptions in the AWS, and this high availability and operational performance will be largely achieved through the redundancy and automatic failover mechanisms. So here one of the major characteristic is the high availability and operational performance. Let's take an example with a system. Let's take you are going to have a system with almost all running and performance well, and it is going to minimize the downtime and encouraging the consistent user experience. Then you will train this particular service and to avoid the delays and cancellations. So here let's take an example, online banking, which will be available into 24/7, but sometimes data should be retrieved by the banker, so they will give you the time where the data will be recovered, and at that time the services will not be available. So it may be an high available by 24/7. The maintenance and the performance issues will be rarely occurs, and that should be managed properly. Let's take another example of train ticket reservation, where at 12:30 to 1 o'clock at midnight, all the services will be stopped for the sake of the maintenance or data procuring. So these are the operational capabilities or the abstractions related to the operational performance, and maximum availability will be there for the cloud computing. So it is considered as high availability of operational performance. Next comes to the trade fixed expense for variable expenses. So here, when you are going to start a particular organization, what you need is you have to get the servers and you have to invest for the servers, and you don't have any idea how much expense it will be, and you have to get the system administrators, employment and servers and data security and different softwares you have to purchase. But when you use these all comes under the initial investment, data center investment based on the forecast. That means you are just guessing what is your requirement. But by using the cloud, you can pay only for the amount which you consume. This will reduce the initial investment of the cloud and for the investor, and it will improve the trade with the fixed expense of the with the pay only for the amount which you consume. Next comes to the benefits of massive economic scale. So here cloud AWS cloud provides the economic scale. That means you can increase and you can decrease your resources so that the amount can be saved, and as per the sources of the consumer requirement, as you are buying a large amount of instances or the resources, you even get the discount amount or the billing system based on the resources which you use. This is considered for the benefit for the consumer, and it is considered as benefit from massive economic of scale. Then comes to the next, stop guessing capacity. That means this year you had 1,000 employees and you are working on one particular software, and next year you can, for that particular thing, you need a web server. So you purchase a web server and you are using that particular thing. But you got another project which is related to the database and you have to store it. So again you have to purchase a database server. And if your employees increased, again you have to increase all your equipment. Whereas if it is decreased, you have to no chance of reducing your economy, but your income will be reduced. So here, by using the cloud computing, you can stop guessing the capacity. The overestimation cannot be, there won't be any overestimation or there won't be any underestimation. Based on the scaling, based on the demand, you can use the resources. This is also one of the advantage of cloud computing. Then the next advantage is increased speed and agility. In cloud computing environment, new IT resources can be procured by one click, and these resources you can specify the required time, and based on that required time, based on the developer's requirement, it may be in weeks to the minutes, you can use the softwares or the resources, and you can pay for the what you used. So this is one more advantage, and you can increase the speed and you can as per your professionals requirement. So one of the major benefit is increased speed and agility. Next comes to stop spending money running and maintaining data centers. So here, as you are using the cloud environment, you are going to pay for what you used. If you are using, for your company, you are using the own traditional IT center, you have to maintain the data center servers, firewalls, and all equipment. And this spending, you can stop spending for the money which you are using for the data centers, and for maintaining data centers also a huge costly thing, where you can stop maintaining the data centers by using the cloud environment. So using a cloud environment, we can stop spending money and running and maintaining the data centers. This is also one of the benefit of the cloud environment. And finally, go global in minutes. So as you are online, you can go global, you can go and use multiple regions all over the world, and by using few clicks, you can save your data at secure places with the minimal cost, and it is a greater advantage for the customers in spite of spending money on the traditional data centers. So these are the different advantages of the or benefits of the cloud computing. Once again, I am going to discuss the benefits of the cloud computing. The benefits of the cloud computing are elasticity and scalability, fault tolerance, high availability of operational performance, trade fixed expense of variable expense, trade fixed expense for variable expense, benefit for massive economics of scale, stop guessing capacity, increase the speed and agility, stop spending money for running and maintaining the data centers, and finally go global in minutes. These all are the 9 major benefits for the cloud computing. Now I am going to discuss related to the similarities between AWS as well as traditional IT. The major 4 concepts which we are going to discuss here is, one is security, and another is networking, then comes to the instances, that is compute, and then comes to the storage and databases. So the first one is related to the security. For the security in the traditional IT, the security will be related with the firewalls, ACLs, and administrators. Whereas for the security related to the AWS is security groups and network ACLs as well as AM. There are 2 types of users. One is AM user, that means identity and access management user, and next comes to the root user. Root user is the user who pays the bill for the particular company, and in the company how many employees are there, they will get the access as an AM user. Next comes to the networking. So here elastic load balancing and Amazon Virtual Private Cloud, these 2 works for the AWS, whereas in the networking the others are routers, network pipeline, and next comes to the switch. These are the 3 things which are interconnected with the networking. And after this, the next thing is related to the different servers. Those are the database servers, network servers, database servers, web servers, and other different types of the servers are required, and maintaining these servers is a cost consuming thing, whereas this compute will be interlinked with the EC2 and as well as instances related to the EC2. Next come to the storage and databases. The storages in AWS are S3 bucket. S3 bucket is used for the storage, whereas the databases, AWS Relational Database Service RDS, then the AWS Redshift, AWS Aurora, AWS DynamoDB are the different storage services, as well as the database services, as well as Amazon S3 bucket is used as a storage service. So this is all about the similarities between AWS as well as the traditional IT. Now we are going to discuss related to the AWS global infrastructure. So here the major concept is, it is how globally the AWS having the different data centers, availability zones and regions. So AWS global infrastructure, that means all over the world, how it is interlinked. AWS global infrastructure is the most secure, expensive and reliable global cloud infrastructure, and this particular global infrastructure having different availability zones, regions. So the most extensive global infrastructure consists of 117 availability zones and 43 local zones and 37 regions, which will be connected with the multiple availability zones, and around 700 plus CloudFront and 13 regional edge caches. So here AWS global infrastructure consists of 117 availability zones, 37 geographic regions, and even it is planning to add 13 more and availability zones and 4 more regions, mostly in New Zealand, Saudi Arabia, Chile, and European Union in Europe. So here, this is the place you can see all over the world map, which is dynamically showing you different geographical regions which are in the area of North America. In North America, we had an availability zone, that is US East, US West, and all these are the different zones. Let us check the edge locations. These are the different edge locations in the geographical regions. This is shown for the North America. Then you can check for the South America. You can check for the South America. Then Europe. So these are the places where Ireland, London, Spain. So these are the places where the geographical regions are available. Then Middle East. You can see it, Middle East. Then Africa. Then Asia Pacific. In Asia Pacific, you can check in our India, there is an availability zone. It is in Hyderabad. Asia Pacific is in Hyderabad, and another is here, Mumbai. So AWS is having two places. One is in Mumbai and another is in Hyderabad. So this is the web page where you can see all the different availability zones which are available here in India. Then comes to the next concept, that is about regions and availability zones. As per the global infrastructure, regions and availability zones are used. AWS is offering the different infrastructures for the sake of the regions, availability zones. So this is all about the regions, availability zones, and AWS global infrastructure. Once again, finally explaining you that AWS global infrastructure consists of the 117 availability zones, 37 geographical regions, and 13 availability zones and 4 availability regions are planned in near future. So this is all about the AWS availability global infrastructure. That's all for today. Thank you. Thank you very much.